First thing we're going to talk about is how to calculate atomic mass. You can see the formula for atomic mass is right here at the top of the page here. And the way you do it is you find the percent abundance of compound 1 times the molar mass of compound 1. And then you just add any subsequent isotopes that exist for that element. One thing you have to remember about percent abundance is that when you use a percent to calculate, you have to remember to divide by 100 first. And again, you only do that for percent abundance. You just leave the molar mass by itself. So if we read the problem, it says potassium has 2 isotopes. That's kind of important to know that there's only going to be 2 of them that you're going to use. And it says the first has a mass of 39, and that's supposed to say AMU, and a percent abundance of 93.1%. So I'm going to underline my 2 givens. The second has a mass of 41 AMU and a percent abundance of 6.9%. What is the atomic mass of potassium? So I'm going to look up ahead and figure out my formula for atomic mass is going to be the percent abundance of the first compound. So if I read carefully and I see the word first, I'm going to figure out that my percent abundance for that first compound is 93.1%. I'm going to remember that when you have a percent, you're going to divide by 100. So instead of writing in there 93.1%, I'm going to write in there 0.931. So I've just divided that number by 100. Then I'm going to multiply that according to the formula, which is the molar mass, which is 39.0. And then I'm going to do that math in a second. Next, I'm going to look at the numbers for compound 2. It says it has a percent abundance of 6.9%. Again, I'm going to divide that by 100 to get 0.069, and then multiply that by the mass of 41. I'm going to multiply both of these numbers, so I'm going to put in my calculator 0.931 times 39.0, and I'm going to get 36.309. And then again, I'm going to put 0.069 times 41 in my calculator and get 2.829. And then to get the total, I simply add those together, and I get 39.14 AMU. Remember that your unit for atomic mass is going to be AMU. Now I'm going to go on to the next problem. It's the same formula all the way through. So I'm going to go to the next slide. Again, I'm going to underline what I'm given, circle what I'm looking for. So it says, what is the average atomic mass of copper if 69% has a mass of 63 AMU and 31% has a mass of 65 AMU? Remember, my formula is the same. Atomic mass equals percent abundance times mass. Each time, percent abundance times mass. So I'm going to find that my first percent is 69. Again, I'm going to divide that by 100 and do 0.69. Multiply that by its mass, which is 63. I'm going to calculate that out in a second. Next percent I see is 31. Again, divide by 100 to get 0.31. And the mass of that is 65. I'm going to multiply these two out and get 43.47 when I do 0.69 times 63. And then I'm going to do 0.31 times 65 to get 20.15. Add those two numbers to get the total, and my atomic mass for this number should be 63.62 AMU. I'm going to box off my final answer. Finally, number 6, neon has 2 major isotopes. The first has a mass of 20 AMU and a percent abundance of 90%. The second has a mass of 22 AMU and a percent abundance of 10%. And then again, what is the atomic mass? Same pattern. Atomic mass is going to be percent abundance times the mass. So my first percent abundance is 90%. Again, I'm going to divide that by 100 first, and I'm not going to multiply by 90. I'm going to multiply by 0.90. Multiply that by its mass, which is 20. Second percent abundance is 10. Again, divided by 100 is 0.10. And second mass is 22. I'm going to multiply 0.9 times 20 to get exactly 18. And 0.10 by 22 to get 2.2. I'm going to add those two numbers together to get a total of 20.2 AMU. The key factors here are to remember to divide the percents by 100. Leave the masses alone. You're going to do the calculation and then add together the two separate atomic mass times percent abundance to get the total number.